Continuing with our topic of moments, let us now discuss some examples. Example 3.1 states that a man and a boy carry a weight of 300 Newton between them by means of a uniform pole, 2 meter long and weighing 100 Newton. Where must the weight be placed so that the man may bear twice as much of the weight as that of the boy? Now, if you see this, correlate this statement with this figure, there is a pole which is 2 meter long. The pole is notated by A, B, and the weight of this pole is 100 Newton, okay, which is acting at its center, which is given at a point G. Now there is a force vertically acting vertically downwards 300 Newton, but its location is not known. The location has to be selected in such a way that the man which is carrying this pole carries a weight of 2W, and the boy which is on the left side, that is point A, carries a weight of W. Okay. Now assuming that the distance of this 300 Newton force is at a distance of x from point B, we can solve this problem by first resolving the forces vertically. Assuming that the reaction, that is the support which is given by the boy, is W, and that given by the man is 2W, the total sum of the forces which are acting upwards is W plus 2W, and which is to be equated with the 100 and 300 Newton. Okay, and in this way we can find out the value of W. Now we can find out the moment of all these forces about any point on this pole. Let us take a point of A with, for calculating the moments. So moment of this 100 Newton force will be 100 into 1 acting clockwise. For 300 Newton it will be 300 into 2 minus x acting clockwise, and for this 2W force exerted by the man, it will be 2W into 2 acting anti-clockwise. So equating these, we can find out the value of x, which is given over here to be 0.556 meter. That's all this problem. Then coming on to the next problem, which is example 3.2. Again, here the problem is somewhat similar, but let us read it first. A rod of length 5 meter and weight 15 Newton has its center of gravity at a distance of 2 meters from A. Now the center of gravity is not at the midpoint because the rod is 5 meter length and its CG is 2 meter away from A. So it rests on two parallel smooth pegs at a distance of 3 meter apart in the same horizontal plane, so that the equal proportions of the rod project beyond the peg. Now there are two pegs, namely at C, one at C and one at D. They are at 3 meter apart, and another condition which is given is that this the distance, this 3 meter span is equal distance. That is, point C is having a distance of x from point A, and point D is again having a distance of x from point B. Okay, so these are the forces. Remember that this at point A and B there are no forces which are given because the rod is being supported by the two pegs at C and D. There are no other supports at A and B. You can ignore these two arrows. That is what I meant to say. So again, resolving the forces vertically, there are only three forces, one at C, one at D, that is a reaction R and S, and 15 Newton force downwards. You can find out the you can have this equation, Rs plus is equal to 15. Now since the distance AC is x and dV is again x, you can find out the moment about point C first. Okay, because you see there are three unknowns in this problem. One is distance x, then reaction at c, that is r and s. So we need three equations. So first thing is we have this equation which is vertical resolution of forces, and then we will have the moment about point c. Okay, so when we find the moment about point C, we have the moment of this 15 Newton force. This is 15 into 2 minus x, and that is the distance CG in the clockwise direction. And for S, you have uh, the distance GD into the reaction S. Similarly, you can find the moments about point D, and that gives you a third equation. And by solving these three equations, you can find the three unknowns, which is x is equal to 1 meter, r is equal to 10, and s is equal to n. This was a second example, and now the third one will be example 3.3. It is again a simple problem, which is a bell crank lever AFB. Now there is a it is hinged at point F, and when you apply a force of 100 Newton at point A, this is to be balanced by weight of W given at point B. Now simply in this case we have to take the moment about F. Okay, so 100 into the distance, perpendicular distance between A and F is 20, and the moment of W is W into 5, which gives you this equation, and you can find out the moment. Okay, and let us move next to example 3.10. Yeah. Now, in this example, which states like this, the lever LMN of a component of a machine is hinged at point M and is subjected to a system of coplanar forces as shown in the figure 3.39. Neglecting friction, determine the force P, which is given over here. All the forces are numerical values are given, but for P it is not given. And next thing we have to find is the magnitude and direction of the reaction at point M, because these forces are acting on this point L and point N, and there must be some reaction at point M too, because the system is in equilibrium. So we will apply two conditions here. One is equilibrium of the moment, that is the sum total of the moment about point M will be equal to 0, because these two forces are given 600 Newton, 400 Newton, and we will find out the moment of these two forces about point M by taking the force into the perpendicular distance. And then for point P, the angle is given to be 60 degree with this line NM. The angle is 60 degrees. So again, we will find out the component of this force and the distance, perpendicular distance. Okay, now this will give us the value of P. The second thing we want to find out the reaction at M, that we can simply find out by resolving the forces, all the forces, after we find out P by resolving the forces vertically as well as horizontally separately, and finding out those sum total of these individually. Okay, so let us see the first one. Taking moment about the hinge M, we have this 200 this is 200 is the distance. So what we will do, we will find out the component of this force P along this line, which is perpendicular to Mn, and multiply it with 200. Then again we will find the moment of 400 Newton force and find out this perpendicular distance, and then 600 Newton force and find out the perpendicular distance. Okay, Okay, sorry, for 400 Newton, the perpendicular distance will be like this, and for 600, it will be like this. Okay, so first equation gives us P as we discussed, and P into 200 into sine 60 is equal to this equation, which is this force, moment of this force 600 force, moment of 400 force, and we can find out the P. Okay, and then magnitude of reaction at M. So we'll find out sum total of the horizontal components and sum total of the vertical components, find out the resultant by using this equation, and then ultimately the tan theta of the angle of the resultant, that is tan theta is equal to sum of the vertical components divided by sum of the horizontal components. Okay, so this is the these are the four problems that we discuss. Okay, so we'll discuss two or three more problems in our next video. Thank you.